Okay, hello everyone. So today's session we cover the operating system of all Huawei devices, which is called the VRP Visual Routing Platform. We'll basically discuss system file operations and the basic configurations that we can have. But obviously, we'll start by introducing the operating system, which is basically the brains of all the Huawei devices, which is called the visual routing platform. Objectives of this course is to understand the VRP basics, learn how to use the command line interface, master the basic commands. Now, what is VRP? Like I said, visual routing platform is basically the brains that runs the devices as much as Microsoft Windows 11 is the operating system of most of our computers. That's the brains of our computers. Android, your iPhone uses what? iOS. I'm not so sure what's the name of iPhone's operating system, but those are the softwares which run the device basically. For Huawei devices, that software is what we call the VRP. And what it does, uh, one provides user interface and unified management interface. So basically, it makes sure all the devices have sort of the same look, have the same look, same feel. Hey, I just exhausted my data here. Right. All devices have the same feel. Um, if you're trying to access the user interface on all the Huawei devices, you get sort of a unified user interface. The reason why is because of that VRP. Then it is also responsible for handling routing. Here is highlighted as implementing the functions of the control plane and define the interface specifications of the forwarding plane. So when we talk of the control plane, that's basically where routing takes place. Uh, then it also defines how the forwarding plane, which is the hardware, which does the forwarding of my packets, should basically behave. So the control plane is that is where the decisions for forwarding traffic are made, and the forwarding plane is responsible for forwarding my packets basically. So what controls all that the control plane and the forwarding plane is also that same software, as the VRP. Lastly, it is responsible for implementing communication between the device forwarding plane and the VRP control plane. I think almost same thing with the last one. With this one, ensuring that my decisions that has been made by the control plane are correctly applied uh, by the forwarding by the forwarding plane. So in short, the VRP is what makes the hardware of all Huawei devices tick. Now, development of the VRP, someone confirm I'm still online because I had a couple of network connection issues. Uh,
Yes,
thank you.
we can see.
Right, development of the VRP. So on that image, we basically have an illustration of the development of that software, starting from its inception, that's 1998, where we have the version one of that software, all the way up to 2009, where we have the version 8, which was introduced. You can see on my file right here. So this is sort of the evolution of the software itself from 98 to current date. So currently, you can imagine we're using the version. version 8, as well as the version 5. For specific devices, though, you can see my devices are about version 5. We have the ARC routers. Then on the other end, we have multi-chassis devices. So these ones are supported by the version 8 of our software. File systems. File systems manage files and directories in storage media, allowing users to view, create, rename, delete directories, and copy, move, rename, and delete files. Right. Key things here is understanding what a file is, what a file is, what a directory is, what is storage media. So when we're talking of our devices, uh, we define a file being basically, how do I put this? Basic unit of storage. By the technical definition, basic unit of storage where the actual data is held. That's what a file is. Our devices are not transmitter data. Um, they create, they transmit data, they copy, move, rename data. Data error is stored in what we call a file. Then a, a directory is sort of a container which contains that file. So it's sort of a folder. So with our devices and through our VRP, our operating system use, realize we create my files, we store them in my folders, and I got it arranged in my folders. So my folders is basically used to manage them. Then everything is stored by storage media. We have different types of storage media we're going to discuss, Pamberi. Example, and RAM, SD-RAM, NVRAM, USB, etc., etc. So basically, that is what defines those three things. Ungazibata you realize mastering the basic operations of the file system is crucial. Is for you to understand how to efficiently manage my configuration files on the software Yedu, which runs our hardware. Now, the type of files, common file types that we have my system softwares, which are basically the operating system, if I can say. This is what is used to start up my devices. Edu. I think in short, this is operating system, and you can see them by file extension EO CC. We have my configuration files, and these ones I used to store my commands. My commands adaptation is to give instructions to my devices. They are stored in my configuration files, and you need to take note of my extensions are. Then we have my page files used in fixing bugs, usually for troubleshooting, and .pat, that's our extension. Then we have my PAL files. Yeah, these ones are called product activation files. Yeah, product activation files, which are basically used to enable license function on my devices using the file extension bin. Yeah, this one I find it very, I use it very commonly when I'm kind of try to create some of my softwares you make use of folder rename extensions against .bin, copy paste on some folder against .bin. Next time I'm trying to crack, maybe it's information you might try to find with these users. Right, storage media, different types of media we have. We have the NVRAM, which is non-volatile random access memory. Basically, this one is used log buffer files. It is used to store log buffer files. It's a bit different from I thought it would be the same with Cisco devices. The NVRAM is usually used to store the startup configuration files, but here it's a bit different. I think it all depends probably with the architecture of this specific vendor. So the NVRAM here is used to store log buffer files, and with log buffer files, these are files which are used mostly to make sure that our system messages are logged on time. So the system edo the messages are not sent one of events if needed at times, but not gonna my alarms. Ese we call them logs. In logs where they are stored in the NVRAM. I think that's the specific function of the NVRAM in Huawei devices. Then we have the flash, which is also a non-volatile memory where you can avoid data loss in case of a reboot. Device that going to get power off, you can avoid data loss. So that's flash for you. And it is used to store the system software and the configuration files. So I think that's where it's a bit different. So the flash in this case, dominant operating system, dominant my config files it as well. So my startup configuration files. Then we have the SD-RAM, synchronous dynamic random access memory, which is equivalent to the computer's memory. So this one is generally called the RAM in RAM used to store the running configurations, the system running information. So when you are running your device, uh, there are a set of commands that are per device giving it instructions. But when every command, that is what we call a running configuration. My commands are save in this storage media, the RAM. Then if you save those configurations to the device, uh, they are then moved to the flash. If you do not save them, device are going to get a reboot, you lose all those files. Don't get really running knock, but if you save them, you move them to the flash, therefore you can avoid that data loss. Then we have the SD card and USB. I think those are sort of external storages with the SD card having a large storage capacity and generally installed on a main control board used to store system files, configuration files, log files, and so on. So you can see, I think its use is almost the same as this one plus this one. But the difference is this is sort of, I don't want to say, it is external, removable, let's say removable. SD card, this is removable storage, but having the same function as the flash and the NVRAM. Then the USB, almost the same case, very useful when we are doing my device upgrades and data transmission, when you want to transfer my files, when you want to install my operating systems, we all know what a USB is. Right, device initialization, very important. You need to understand good power is your device gets and you switch it on for a router or just a switch. Power is my gets. What does the initialization process look like? Boot up process. It's weird. Um, Different vendors they use different type of languages, but almost explaining the same thing. In Cisco, for those who did it, this is sort this is called the boot up process. What am I doing? Boot up sequence, boot up process. I think it's almost the same thing. After a device is powered on, it runs the boot ROM software. In Cisco, that's the bootloader software. So I think, let me put it this way, device initialization, you need to understand the process yekuti device rako switcher on up until user interact with the command line interface. What's that process like? So the best way to understand it is looking at the different memories which will be accessed during the switcher process. So the first memory which will be accessed patinotanga is the ROM VRP, read-only memory. Right, the read-only memory is accessed to, let me see, device management. Those are requests. Okay, the ROM is accessed to initialize process here in Tangira, where we have the self-test, self-test here, where the hardware is tested to see if our device is functional. So the device tests itself to see if it is functional. Then in this memory, that's where we have the boot ROM software. The boot ROM software is used to find where the operating system is. So Panapa plus software bootloader is in the ROM. Then we go to the flash memory. So this software finds the operating system in flash and loads it. So this one, a flash memory, finds the operating system, loads it. Then we go to, since my configuration files, they're also in the flash operating system, we have my config files, startup configurations. Yamawana, they load the device, the operating system loads the startup configuration files. That's when you start seeing um, some information in get per user interface here. In this case, we can talk of the command line interface. My config files, they are loaded to the running configs. Then my running configs, basically ndo paunoona pauyi pako for those wakwanisa kuita malabs. I think ndo paunoona something like this, showing the device rako is now on. You can now start making my changes on it. Yeah, it's a bit not perfect, but very important to understand the initialization process, the sequence yacho, and the easiest way to do that is to describe it in terms of my memories being accessed per my devices elu. So we have the ROM, we have the flash, then obviously my running configuration that's another memory RAM. So understanding these different type of storage media and understanding how they're important in the initialization process, uh, it's a must know. Device management, two common ways of device management with the CLI and web system. So basically, how do you manage a Huawei device? How do you get access to it? And then manage it. Access is usually it's either via the console cable, that's using a local port, which we call the console serial port, or you can get access via remote methods. We have what not my VTY ports, my VTY lines. My VTY lines, basically those are virtual ports we can use for remote access, Ashanti, Telnet or SSH. So if you use Telnet, SSH, or the console port, then you get access to manage your device via the command line interface. Command line interface, text-based. So to give instructions, you're not going to type my text using the command line. Then another way, you can use the graphical user interface via the web system. So using my protocols here, the HTTP and HTTPS, you access the GUI, the graphical user interface. Then you can start making my changes on your device, manage your device. This one is very common. I'm sure that I'm in my MiFi this method ish, shandiswa to get access to your Wi-Fi. I think it's a mini router of some sort. So if you want to get access to it and manage it, unoneza the IP address Wi-Fi yacho, then orisa pa web browser yako, or access the graphical user interface of that device. It's almost the same concept for those on sama Wi-Fi. Then user interfaces. We have the console user interface, we have the virtual user interface. So with the console, like I said, this one uses the console port, also called a serial port. Then with the virtual user interface, we are using my virtual lines, which are virtual ports, which are used to access our device. Uh, Very useful for remote access. User levels. User levels, here we discuss VRP providing basic permission, control functions, defining the levels of commands that each level of user can execute to restrict the operations of users at different levels. So with these levels, it's basically a way of restricting sensitive commands. There are some commands that ikaiswa pa device network yasenegona shut down. Those commands, they need to be restricted from authorization should not be for everyone. So my levels are my VRP user levels. They basically define what a user can do at a specific level. So my regular users probably anongwari level 0, they cannot do much. What they can just do kuisa my basic tools like ping, traceroute. They don't affect the network that much unless I square at a bulk, which is a bit difficult. It doesn't make sense as well. But it doesn't affect my devices as much. So my levels as we go, privilege level, I know increase and the amount of access, the amount of privilege that you have, increase. So from visiting level, monitoring, configuration, then to the management level. Are my levels sort of where basically you have complex system configurations and ingareko. And for you to be authorized to do that, it means no resource of it. So my user levels, in short, they are used to restrict what users can access when they are managing my devices here. Typical questions and open over could a user, for example, a user aikwanisa kuchinja ma-routing commands. So i-level ripi rahari, which level is that, which user level is that? So you need to be able to identify some of those things. Here, that's an example of how we can manage our device via the web system. So you can see you just access the device via its IP address. Simple concept. Then local login, this one is via the console. They tried by all means to show us what a console cable looks like. So a console cable in a one end in RJ45 connection, then another end in a RH232 port. This end in the another PC probably in the console hero RJ45 end yenda ku computer yako desktop. For my laptops, this end unongona USB. Or you could have an adapter, change this RS232 port to USB. Simple concept. So to access this device via this cable, you just connect it, then you connect your computer kwako. Here you need an application which will allow you to manage that device. Application here, the most common example is this one. Party. So this application then also allow to get access to the terminal. paterminal ndo paunotanga kuita configurations, etc., etc. So if we are using these are the options of access methods that now, if we're using a console cable, I don't know, click open serial. If you're using SSH, you click here. If you're using Telnet, you click here. Then if you're using Telnet or SSH, there'll be need a visa IP address. I think the section is not there up. You just input the IP address, then you open a session, and voila, unongwapinda in your command line interface. No command line interface here, and that is what it looks like. So for most of the configurations that need cheater will deal with them in the command line interface. Literature says the command line interface uh, is a bit flexible. It allows user kupinda deep in system and make my changes in system. As much as the graphical user interface is very easy to use, but it's very limited as well. There are some things also not with the Oracle graphical user interface. That's why we will focus on the command line interface as my engineers. Basic command structure. So my commands ADS, they are made of the command, the keyword, and the parameter values. And the command, it specifies the operation which needs to be executed. Then we have the keywords, which are sort of an extension of command edu, as well as my parameters edu. Example, which was given here, in a display IP interface. This is, it's difficult now to say it's a command. Okay, this is a configuration command. Configuration command in structure in arrow. So if you look at display E, do command AD, right? It specifies the execution. So execution here don't display something. From display, you can display a lot of things. You can display my IP address, my device, you can display routing table, you can display the MAC table, you can display information about the routing protocols that you are using. You can display the running configurations. There are a lot of things you can display, but the command is display. So to be more specific, there is need for keyword now. Without display A, B, C, D, you specify what exactly are you do you want to display. So in this example, we are displaying IP. So this becomes the keyword. We are displaying things to do with IP. Then from there, we have my parameters edu, which can be multiple. It could be my parameters with names, or it could be my parameters with values, or it could be both. In this case, we have a parameter, which is an interface. This is the name. Then a value of that interface, Giga Ethernet 000. Not very important. Kana mapabasa, but very important. Kana mfunzo yabvunzwa. You could just be given a command like this one, configuration command like this one. Obvunzwa nje, what are the parameters repap? Two answers zotouya. So you just have to know kuti command structure yakaita sei. How do you differentiate between a command and a keyword? And my parameters acho, how do you differentiate between that? And basically, that's the structure of my commands edu. Then we have my views. We have what we call my command views. And my views basically provides, facilitate the use of commands, registers the commands in different views according to their functions. So what my views do, it registers my commands edu depending on the function that they have. So different views, we have different functions. The main primary view, paunosvikira uchipinda padevice yako. This is what we call the user view. Let me check. Right, user view irapai. And how do you identify it? When I identify it to my out to troubled. Those are not user view. And I think for this one, Tatapinam system view, you can see my brackets are a changer, square brackets. That is how you identify system view. As you do practice, as you do practice, it's very important knowing good remove view heap, because specific commands work in specific views. My views is also another way you will limit out what can be done in a specific view. So the user view is the first view that we have, and we don't have much here. We don't have much configurations in this view. So the configurations are remote at the basics. They don't even change much on the running of the device. Then we go to the system view, which is sort of the gateway to all other advanced views. So you can see from the system view takaenda to my advanced views edati now, the interface views kwatinoisa ma-interface edu. For example, kana uchida kuzoona configure your IP address, you go via this, open up interface views, then uchizoassign your IP address. Then we have my OSPF views, where you can configure my settings for your OSPF protocols, etc., etc. So the system view, like I said, is the gateway to all other to all other um, to all other views, sub configurations. For those who did Cisco, I think it's the same thing with my mods, the user exec, the privilege exec, the global. Yeah, we don't have the privilege exec. We have the system view, probably the global. Then the other sub configuration commands, same difference. Command views. Yeah, it's basically showing. Let me see. It's showing ways to navigate between my views edu. So starting point edu here, this is our view, user view. Kana tauda kuenda to the system view, tunaweza command irape system view. Then kana tauda kuenda to the interface view, ndesa command ir, starting with the interface command. And our parameters, uh, parameter name and parameter value there. What's the command, Panab? Interesting question, and what's the command? What's the command structure here for this one? Multiple answer. What's the command? What's the keyword? What are the parameters for this one? It's a command yet no consider trim system view. But continuing navigation here from, if you want to go back to the view you have before, you just quit and you go back to the previous view. Same here, if you quit, you just go back to the previous view. I think that's another quick return. Kana uchida kubva from these advanced views kudzokera directly to the user view, you can just use the return command. So I think from wherever you are, if you put this return command, inongokudzosera to the user view. So basically, that's how you navigate between my views right now. Checking my time, if we are going to close, I use the same link. I think we'll just have one more session and we'll be done. Editing a command. There are times you need to edit my commands, which I don't expect, but it will happen. You can use the backspace to delete left, right keys to just navigate through what you want to change. There is also the incomplete keyword, which allows quick entering EMA commands. In this case, a device allows the input of an